Hey guys, today's lesson is going to be quick and easy because we're going to work on area. We're going to go over a few formulas that you may have forgotten, and we need these formulas to do the area of complex figures. First of all, a complex figure could be something that has a rectangle and half a circle and a triangle. So basically, if they ask you for the total area, you've got to work out all three areas, add them up, and get the total area. However, if you don't know the formulas, you're stuck. So let's get with something very basic first. A rectangle area is length times width. Length times width. A square, where all the sides are equal, is also length times width, but because the length is the same thing as the width, we say length times length, or we can say length squared. It means the same thing. Then we get to things like a rhombus, which is a square pushed over to the side. And this rhombus, you cannot find the area unless they give you the perpendicular height. Perpendicular means it sits 90 degrees on top of the base. So this will be the base, this will be the height. How do I know which is which? Because where the base and the height meet is a 90-degree angle. We say that they are perpendicular to each other. So this area would be base times height. The same with a parallelogram. A parallelogram, it's a rectangle pushed over to the side. I also need the 90-degree height and base because its area will also be base times height. Please take note that this base is a lowercase b, not an uppercase b. In math, in geometry, an uppercase b means something different. We'll get to that. Okay, we get to triangles. Triangles, okay? On a triangle, you've got a slanted side and a slanted side, sometimes just one slanted side, but the point is, you don't need these slanted sides to work out the area. Again, just like the rhombus and the parallelogram, it needs a 90-degree base and height, but because it's a triangle and these two sides come in, they come together, they're making the original shape smaller, we got to divide the base and the height times 2. So this area would be base times height divided by 2, okay? If it was not divided by 2, you would have found the area of a rectangle, okay? So it needs to be divided by 2. Then we get a trapezoid. Trapezoid, okay? Trapezoid has one set of parallel lines. This is important because on a trapezoid, you're going to use the base and the height, which sits 90 degrees on top of each other. You're not going to use the slanted heights. No. You're going to use the 90-degree base and height, and here's what you're going to do. This height touches a top line here. We call it base 1. It touches the bottom line at a 90 degrees. We call it base 2. And here is how you work out the area. The area is when you take base 1 plus base 2. You can see I'm putting them in parentheses. They're going to be added. Then they're going to be multiplied with a 90-degree height. Then everything is going to be divided by 2. Alright? Now these are the area formulas that I can think of. Please memorize these, and today we'll work on some complex figures that you need to find the total area of. Okay? Thank you guys.